Hi everyone and welcome back to the garage. In this video we're going to be discussing fuels. So crude oil, hydrocarbons, gasoline, and diesel, and some of the terminology that goes along with them. So you may have heard of crude oil, and you may have heard of hydrocarbons, but you may not know exactly how these things get processed into diesel fuel or into gasoline or into the other chemicals that we make out of them. So that's what we're going to start with. Crude oil gets pumped up out of the ground. You may have seen pictures of an oil field where they have the big pumping mechanisms. It's a big piston pump that goes into the ground, and there's these like linkage things that go up and down. And they pump this crude oil out of the ground, and it's this kind of gross, stinky substance, and it's got a whole bunch of different chemicals all mixed together in there, and they're all good for different things. So we need to process this crude oil. We need to basically break it down into separate pieces. When you break something down into pieces, you get what we call fractions. So they're going to take this crude oil that they pump out of the ground, and they're going to put it into something known as a fractioning tower. So inside this tower, this fractioning tower, they're going to bring in the crude oil and they're going to heat it. And what's going to happen is the different molecules, the different chemicals that exist inside this crude oil are going to start to separate out, with the more volatile or more easily vaporized materials going up to the top of the tower, up to where it's cooler, and the thicker, heavier products that don't boil as easily, that don't vaporize as easily, remaining down at the bottom. And what they're going to pull off the top is basically going to be gas. So chemicals that very easily boil off or very easily vaporize, don't have to be heated all that much, and they vaporize out. So those vapors, those gases get collected, and they make various chemicals out of those. Just below that, there's going to be a tray. There are actually several trays. And those trays up towards the top are going to collect the relatively light products that boil off at a slightly higher temperature than the fuel gases. And right down here where this tray is, they're going to condense. Those things are going to condense into this tray. Chemicals that condense in that tray are going to come out, and this is the stuff we use to make gasoline. A little further down from the gasoline, there'll be another tray. The products that condense in this tray at a slightly higher temperature are going to be solvents. So things like mineral spirits and stuff called naphtha and other solvents that we use to make various chemicals. Below that tray, again, we're getting lower down, we're getting closer to the heat source. So higher temperature items, the stuff that's going to condense in here is going to be your kerosene. Further down from that, we're going to get our diesel fuel. A little further than that, almost done here. These trays are going to collect different fuel oils, things like jet fuel, things like fuel for big cargo ships. It's thicker than diesel fuel. It's a heavier fraction, they call it. And then down at the bottom, basically we've got glop. So the stuff that's left out at the bottom, the real thick, heavy stuff that never really boils, it just kind of becomes slightly liquefied when heated and wants to go back to a solid when it's cold. That's the stuff we use to make asphalt and tar roads and things like that. So real heavy stuff stays at the bottom. So these are the fractions, and mostly we're concerned with these guys for the purpose of this lesson. Not even so much the solvents. We're more interested in the gasoline, the kerosene, and the diesel. So gasoline is said to be a lighter fraction than diesel. Basically, it boils off at a lower temperature, so it doesn't need to be heated up quite as much to become a vapor. You can prove that to yourself. Just look outside on a hot day. If you spill a little gasoline on a concrete surface, it's going to evaporate away right away, whereas diesel is going to kind of stay there and make an oily stain. So it doesn't vaporize quite as easily. And that has to do with the types of engines they're being used in. In a gasoline engine, as you know, we vaporize the fuel and we ignite it with a spark. So obviously not a whole lot of heat is required to ignite it. Whereas in a diesel engine, quite a bit more heat is necessary to ignite that fuel. And that's actually a desirable thing. It's a compression ignition engine. If you were to put a light fuel in there that were more easily vaporized and more easily combusted, the engine would knock and kind of probably damage itself, make some bad noises. So these fuels are suited to their purposes. Now the stuff that comes out is not pure. It's been separated into fractions, but this stuff still has to be processed. Certain additives have to be added into these products to get the desired characteristics we need in an engine. For instance, in a gasoline engine, we're very concerned with deposits and cleanliness, keeping the back of the valves clean, keeping the fuel injectors clean, the combustion chambers clean, not filling our catalytic converters full of soot and deposits. So there's certain detergents that have to be added into there, and there's certain other chemicals that enhance the way the gasoline burns. And diesel is similar. We have to also treat diesel with some different additives. Okay, so we'll start with gasoline. So basically it's somewhere from 5 to 12 carbon atoms in a chain with a bunch of hydrogen atoms sticking off. For that reason, we call this a hydrocarbon. So there'll be differing molecules in the gasoline, different numbers of carbon atoms, obviously different number of hydrogen atoms, and they'll add different chemicals in, different things that they've pulled out of the gasoline so that they can control the levels of it. So some of those fuel gases can be turned into useful products to be put back into gasoline to enhance its ability to vaporize. Some of the solvents can be added back in and can be refined into different products again to change some of the characteristics. So some of the characteristics we're looking for are its ability to vaporize, or what we call its Reed vapor pressure, or RVP, its ability to resist detonation, which we'll talk about in a later lesson, but detonation is an uncontrolled form of combustion in the combustion chamber where the gasoline doesn't burn evenly and steadily. It's more of a violent, rapid, almost like an explosion, and it's bad for the engine. It makes a knocking sound and it creates pressure waves and pressure spikes inside the cylinder. So we want to avoid that. And it's detergency. Basically, we want to keep the engine clean, free of deposits. How cleanly it burns. So it's all kinds of different chemicals, and I certainly don't claim to be a petro engineer. I don't know all the ins and outs of the chemistry that go on here, but I can tell you about some of these things that we need to know about. So the Reed vapor pressure, or the ability for this fuel to vaporize, is very important to us, and almost even more important to us, the ability to resist detonation. So at some point in time, it was decided that the best reference fuel, or the best fuel, or the fuel that exhibited the best resistance to detonation, was a chemical known as isooctane. This chemical was considered to have ideal detonation resistance. So when we go to the gas station and we see the numbers on the pump, the 87 octane, the 89 octane, the 93 octane, we're basically comparing that gasoline to octane. So octane is like a reference fuel. It's a comparison that we're going to make. I'm going to take a peek at my timer here. Yep, doing pretty good. Okay, so if you get 87 octane gasoline, basically it's 87% as good as isooctane at resisting detonation. If you get 89, it's even better. If you get 93, it's even better at resisting detonation. Does not necessarily make it a better fuel. Some people say that you'll get better gas mileage out of 93 octane fuel. There's been many tests and studies done on that. There's some theory behind it, but basically it's almost non-existent. Some people will buy the 93 because it says premium on the pump, and they're sort of playing a trick on you when they call it that. So by premium, that word kind of invokes this thought that it's better, a better product. And it's better in one way. It's better in its ability to resist detonating in your engine. So if your car doesn't require 93 octane fuel, you're really not going to gain anything or benefit by using 93 octane fuel. Some of the fuels that you can buy, some of the good name brand ones, or what they call the top tier fuels, will have better detergents in their premium fuels. So that is a benefit, I guess, but it's, again, pretty minuscule. It's pretty minor. The lower octane fuels, if that's all your car calls for, that's really all you need to be buying. And sometimes the price difference is pretty staggering between them. Now, on the other hand, if your car takes 87 octane fuel, if they tell you in your owner's manual that's all you need to use, and that's perfectly fine for that car, let's say it's a non-turbocharged, non-supercharged, just naturally aspirated engine, doesn't have super high power output. Basically, it's not going to have very high cylinder pressures, so it's going to be able to resist detonating just fine with 87 octane. You can put 89 or 93 or Ultra 94 if you can find it. You can put higher octanes in there and it will not hurt anything. It's just not really going to benefit you in any way. On the other hand, if you have something that's got a turbocharger or a supercharger or some sort of power adder like nitrous oxide injection, if it's something you've modified to have very high compression, if it's an older classic muscle car from the 60s, their combustion chamber shapes weren't necessarily ideal back then, you probably do need the higher octane fuel. You probably do need the 93 octane. And those engines actually can be harmed by going too low on the octane, because this is going to be less resistant to detonation. Makes the engine more likely to detonate, if that makes any sense. So, your octane rating is your ability to resist detonation. And just know that more is always safer. Not necessarily better, but safer. So, as you know, I drive a turbocharged vehicle. I have to run 93 octane fuel in my car. I've never tried running the regular 87 in it, and I really have no reason to try. I don't put on enough miles to really notice a huge hit in the wallet when it comes to buying the more expensive fuel. So I just buy the premium stuff, and I kind of don't worry about it. So they modify the octane in a few different ways. It's mostly done by the additives that they put in the fuel. And over the years, the additives have kind of changed a little bit. So we'll come back to this vaporization thing here. Way back in the 1920s, I believe it was an engineer that worked for General Motors, discovered that tetraethyl lead also abbreviated TEL, was an additive that could be put into gasoline that significantly raised the octane. An octane enhancer. The only problem with it was lead. poisonous. And after years of studies, they actually found that by the 1960s or so, everybody's lead levels were elevated. They actually kept track of this. Doctors were noticing that people's lead levels were elevated, and they attributed it to contact with gasoline and contact to exhaust from vehicles. So at some point, the EPA and maybe some other regulatory groups got together and decided that they were going to ban the use of tetraethyl lead for public safety reasons, for health reasons. So they had to come up with another way to resist detonation. So they've tried different chemicals over the years. By the way, when they took this stuff out, that's when they started calling it unleaded fuel. So one of the chemicals they tried in unleaded was this stuff called MTBE, which stood for methyl tertiary butyl ether. And you don't really need to know that, but if you've ever heard of MTBE, it's kind of a nasty chemical. It's poisonous. They stopped using that because they found it gets into groundwater supplies, so that's not good. And they also discovered something called ethanol. And of course, we already knew what ethanol was. It's basically grain alcohol, but they found that not only can it be a motor fuel on its own, but it raises the octane level and the ability to vaporize of gasoline. So they started using ethanol as a fuel additive. And currently they're using 10%. So in current pump gas, in the US, you can find up to 10% ethanol. So raises the octane. In addition to that, it burns very cleanly. Ethanol burns clean, doesn't leave a whole lot of deposits in the engine. It is considered an oxygenate. It adds oxygen to the fuel, so it burns better. And it's renewable. It's relatively easy to make. So ethanol can be produced from distilling all kinds of different things, all kinds of different crops. Most of it in this country is made from corn, but we can produce it from a lot of different things, which makes it renewable. It's renewable, it's clean, it raises our octane, and in another lesson, in another video, we'll talk about some of its not so endearing qualities. There's some bad things about ethanol and gas too, so we'll talk about that. So, for now, we know that tetraethyl lead, or lead, was once used to enhance our octane, then we stopped using that. Not only because of public health, I should also mention, when the catalytic converter debuted in the 1970s, it was found that the lead in gasoline would foul up the catalytic converter. So with catalytic converters, you can't run leaded fuel. If you can get your hands on leaded fuel, it's still available for off-road uses, particularly airplanes. A lot of small aircraft need leaded fuel. If you put that into a car that has oxygen sensors and or a catalytic converter, you're going to be needing some oxygen sensors and a catalytic converter pretty shortly. So we got rid of lead, we got rid of MTBE, and currently we're using ethanol as our most popular octane enhancer. So some people talk about how ethanol can be kind of a bad thing. Well, I'll tell you what, if you remove the ethanol from your gasoline, you no longer have the octane it said you had on the pump. So just something to keep in mind. If it was 87 octane and you got the ethanol removed from it, and again, I can talk in another video on how to do that, you don't have 87 octane anymore. It's much lower. It's probably down around 82 or 83. So that's kind of a problem. Okay, so that's our gasoline. Here comes my time check. Okay. Let's take a few moments and talk about diesel fuel. Okay. As we saw earlier in the video, diesel is a heavier fraction of the crude oil. It comes out of a different tray, a little bit lower in the fractioning tower. It's a heavier element. It's a heavier end of the fuel. So it's a little bit thicker. It's got more carbon atoms than gasoline. Okay, longer chains of hydrocarbons. It's less volatile. And we should probably take a moment to talk about the word volatility. So when something is volatile, that means it is easily vaporized, or it's easy to make into a vapor. So by less volatile, ability to vaporize. Less volatile basically means it's going to take more heat to make it into a vapor. So you're going to need a higher temperature to ignite it than gasoline. Okay, it doesn't ignite as easily. And it's also rated differently. So because a diesel engine runs a little bit differently than a gasoline engine, we don't compare this to octane, because octane is not the ideal fuel for a diesel engine. So there really isn't an octane rating of diesel fuel, but there is what they call a cetane rating, and that's controlled by some additives that we can put into the diesel, just like we control the octane of gasoline by the additives. There's going to be some detergency additives added in there because despite some of you folks that want to make your diesel engine run less clean and blow smoke everywhere, the manufacturers actually want the diesel engines to run as cleanly as possible so that we're not fouling up our particulate filters and we're not blowing black clouds everywhere and basically turning the public off of diesel technology. So there are some detergents in there. They control the amount of sulfur in the diesel fuel. So most common diesel fuel is what they call number 2 grade. Diesel fuel number 2. And as the grades go, the higher the number, the thicker they are. So number 1 is a little thinner. Number 2 is a little thicker. Number 3 is thicker still, etc. So a little joke I like to make, how many C's, that's how thick it is. All right, 3 C's, it's real thick. All right, so we usually use number 2 in the winter time. They will blend in a little bit of number 1 to thin it out, because one of the major components of diesel is paraffin wax. And if you know anything about wax, like think about a candle, if you heat it up, it melts. If you leave it alone, it turns to a solid. So we have to kind of make sure this stuff flows, and there's some additives you can put in your diesel fuel to help with the winter temperatures to make sure it's still going to flow, and hopefully your vehicle, your truck, or your tractor can still start. But so the number 2 is most common, and check my time again here, so I don't want to run out of time. I'm going to run out of time in about 3 minutes here. While we're on the subject, number 2 fuel oil that we use for home heating is basically the same thing as diesel, only it's not quite as filtered, it's not quite as refined, and it's dyed red. And the reason is you don't pay any road tax on number 2 fuel oil because it's not meant to go in a motor vehicle. So they dye it red, and the reason for dyeing it red is if the DOT were to pull over a truck and find a truck full of heating oil rather than diesel fuel, which is just kind of yellowish, they would get a big fine for basically tax evasion, for not paying the road tax. So just a little interesting thing. That being said, if your house ever runs out of fuel oil and it's going to be a couple of days until the oil company can come and fill you up, you are absolutely safe to go down to the gas station and get yourself some diesel fuel at a much higher cost, of course, and add it to your fuel tank until to get you by until the oil company comes. All right. So for fear of this video timing out on me, I'm going to pause it here, and then we're going to pick up in part 2.